Hi everyone, I am Kiran Bose and I welcome you all to this video. This video is about the application of regular expression in the field of network security. So let's get into it. So what are regular expression? Regular expression are a set of characters that define a specific pattern. So how are they used in the field of network security? These patterns are matched with the patterns which are present in the files which may cause security threats such as phishing, malware, and so on. Regular expressions are basically used in web programming languages, text editors, and other applications. How does a regular expression work? Regular expression use specific syntax with unique characters to generate a certain pattern. These patterns are useful in validating an email, to validate credit and debit cards, and masking essential and sensitive details to find a key in a particular document. Caution: it is also important to test your regular expression with as many test cases as possible in order to ensure reliability and in order to avoid inaccurate data exception. One of the commonly used example of regular expression in the field of cybersecurity is malware signature. So what is a malware signature? Malware signature are signature that are used to detect and prevent malware scripts which may be mixed with the trusted scripts sometimes. So here is an example of how malware signature is implemented in a PHP file which is used in web programming. So regular expression for the particular malware scripts which are commonly used is written, and an MDM check file is written, and a plain text key which has malware is also given. So the structure of the malware signature is as follows. The signature management is the first step, in which the regular expression, the MD5 checksum, and plain text are written, and these are matched and made it into a report which are sent to the third step, which is known as action management. Here there are set of predefined rule which matches the predefined rule with the current exception, and the finally engine decides whether to execute this process or halt this process. Why do we use regular expression even though we have DFAs and NFAs? DFAs, which are also known as deterministic finite automata, has high throughput, but it has too much memory occupancy to implement it, while NFAs has less memory to implement, but it also has very less throughput. So regular expression can be considered as an appropriate solution to overcome DFAs and NFAs in most of the cases. How to approach a regular expression? In the case of cybersecurity or in network security field, we approach regular expression through a process called pre-filtering approach. The main concept is to create a set of regular expression and use it initially to filter out items that don't match. But there are two main obstacles to overcome in this issue. That is, the filtering effectiveness is affected and the matching speed is also affected. So these things are overcome by the solutions of each of the cases by considering it carefully. Filtering effectiveness is sorted out by filtering out the unmatched pattern as much as possible before the second step. In the matching speed, we use a thing called TCAM, which is explained in the next upcoming video thoroughly. This PPT page represents the cheat sheet for the regular expression table, which helps us sort out the unique characters more easily while solving complex problems. So the main things we have to note here are the positive closure, which denotes that it happens 0 or more than 1 times, and the question marks represents the clean positive closure. Positive closure is also represented as a plus symbol, which denotes that it happens 1 or more times. The slash represents it's an escape character. Like slashes represents there is a string after the given thing or so. Dot represents any character. So the bracket gives the range. So it is mainly used after if you want to specify a specific character like hyphen or any letter after a particular command. So the dollar symbol represents the end of the string, and the caret symbol represents the beginning of the string. Other than this, there are some more backslash characters like slash d, which represents only digit, slash b, which represents boundary, which are also important for upcoming solutions. So let us go into the regex print algorithm. This algorithm is used for overcoming the filtering effectiveness problem. So comparing all possible regex prints, the cost is high. So what we will do here is we will sort a regular expression print to a minimum extent that is common for all regular expression, and we will derive a particular regex print which is more efficient and common for the actual regular expression. The steps are as follows. There are actually three main steps, which is the selecting stage, refining stage, and the deciding stage. This actually these three stages are too much complex. I have given it in a simple form. Selecting stage is the selecting the regex prints whose expression size values are no more than a predefined expression size for each regex. So it means that it can be a clean closure. So refining stage represents that each regex prints the first character whose maximum permutation values equals 1 should be removed successfully. So maximum permutations are removed in order to reduce the complexity. These regex prints whose individual subsets are included by other regex prints should be deleted accordingly. This is also to reduce the complexity. Regex prints with positioning should be kept as many as possible. So this condition is very important as it decides the perfect regular expression print for the actual regular expression. So the deciding stage filter out the particular regex print for each regular expression pattern in order to improve the efficiency. So let us move into the regular expression print matching algorithm, which is actually a bit complex. So stay with me to understand it easily. So we use something called TCAM, which is a ternary, uh, actually it's a ternary cam, which is encoding with zeros and ones. So TCAM is a special type of memory which takes input of data key to look up address. So it's basically used for searching addresses. It has ternary encoding zeros and ones and certain strings of either zeros and ones, enabling TCAM entry to encode multiple DFA transition more simply. So so the access time is very small, so you can implement it much faster. First match semantic, making TCAM to return the index of the first address for the content that the key matches. So the one who proposed it is minus et al. So he used an algorithm to reduce TCAM space and improve the matching speed. Entry by the help of TCAM capacities, which means it misses the opportunity of encoding transition. Created by non-prefix entries, to solve this problem and reduce the complexity, we had a limitation of encoding. So we use quick McLeod's algorithm. Then we set their destination states to irrelevant term and encoding the remaining transition. The detailed description is depicted in this representation. Most commonly used applications. The first one is the detection of malicious patterns in network trafficking. So, this application can be understood by step-by-step analysis of this process. So, first we use Python language to implement the regular expression. We implement it using an RE module which has regular expression. So re.compile returns an object of the regular expression pattern which is stored in a particular variable. So union slashes represents that union is a string which is followed by any string with select with one or more occurrences, and either this or we have a drop with followed by a string with table, and or we use an or keyword with us followed by a string which has plus 1 and equal to 1. This is a parameter which will be explained in the log step 2. For step 2, we prepare the log data. As you can see, we get the log data from the web URL, and we post it in a separate file to match it with our re.compile object which has the regular expression in it. So if you notice carefully in this, we can see after get search, we have question mark which is clean closure with q is equal to 1 or 1 is equal to 1, which is a malicious thread. So q is equal to 1 means actually 1 represents truth. So it is used for bypassing the security systems. So how it works is when the attacker's crafted query is inserted, the query becomes select star from user, select every table from user where username is equal to true. So it is used to access the username database fully, which is likely to leak the data to third-party resources. So we write a function to avoid that thing. So we kept the log files in a separate file which are read using file module which is inbuilt in Python, and we are searching each line by line, which means we are searching each log file with the regular expression pattern, and if it matches we are printing it that potential SQL injection is detected. So using web developer tools, you can even block the access of the particular user who uses these malicious threads. So the full code is given here for your reference. So let's move on to the next topic, which is extracting and masking sensitive information. This application is also widely used in the banking sector. So basically here also we will use step-by-step analysis to understand this process clearly. So we are also we are using re.compile, which returns an object and stores it in a variable which can be used to search the files later on to see if there is any searching match. So slash b here represents that our boundary bound. So d is slash d represents the digit count. The curly braces 4 represents there are 4 consecutive digits. And the square bracket, as we discussed earlier in the cheat sheet section, it is used to specify a specific character. Here we have used an hyphen or a space. So after the 4 digits, we can either have an hyphen or space. We used clean closure, so there can be a hyphen or space, or there cannot, or there is no compulsion to keep it as it is. So this regular expression represents a pattern that there can be a 16 consecutive digits, or a 4 digit followed by an hyphen, or a 4 digit followed by like that 16 digits. So the step 2 is used to mask the sensitive information. Once the backend developer gets the text, we should mask it and we should display it. In order to for OTP generation and other purposes, we have to display it again in the web page. So we should not use the actual full 16 digit code, which may lead to leakage of data. So what we do here is we are using re.sub to match the first 12 characters into a asterisk symbol. So we are getting the 16 digit data and we are masking the first 12 digit with asterisk symbol, and we are displaying only the last 4 digit, which ensures security. And in the third step, we will read and process, which as we discussed earlier, it will open the log file and it will search with each line, and if a particular file is locked, we can even send email to the particular user. So which is very convenient in such ways. If you have to construct DFS or NFS, it is much more complex than you can think. So and it also sometimes occupies more memory. The fourth step is to automate and integrate. So as we know, every regular expression becomes perfect when we automate it regularly. Automation is nothing but we give as much test cases as possible in order to ensure its reliability. Integration with security tools is collaborating with the developer options. You can use additional functionalities like blocking the users, or in this application case, we can send email to the particular recipient that there may be a malicious threat in your code. Please be careful. Or such text can be sent through email, or even we can use OTP generation functionalities too. Here is the full sample code for the second application. We saw what is in regular expression and how do we build in regular expression, and we saw why we use regular expression instead of DFS and NFS. Then we saw a simple application of regular expression in cybersecurity, which is malware signature. Then we saw the approach methods to approach regular expression in the field of cybersecurity or network security, which is pre-filtering approach, and then the obstacles that hinder the efficiency and the algorithms to overcome those obstacles, and then finally we saw the applications of regular expression in network security. So thank you all for staying with me throughout this video, and also I want to show my sincere gratitude to Dr. Professor Satyaraj Segaran sir, who gave me a wonderful opportunity to make this presentation. Thank you.